The last thing we need to do is we need to show that this derivation is unique, because if it has a unique derivation, that proves that you can only draw the parse tree out one way, which means the grammar must be unambiguous. So we can basically augment the exact same proof we did. Clearly for the base case, there's a derivation, and in fact there is a unique derivation. There's no other way to produce epsilon from S. We will assume that for any alpha of this form that there is a unique derivation, and we're going to prove for any beta that there is a unique derivation. And how are we going to do that? Well, if beta has zeros on both sides, then the inside part looks like our inductive hypothesis. So we have a unique derivation from S to alpha. And then how can I use this to get a derivation for beta? Well, clearly, I have to choose S goes to 0, S0 for the first production. If I chose S goes to epsilon, well then I'm not going to get this string because epsilon doesn't start with 0, so that's no good. And if I chose S goes to 1, S1, the strings start with different characters, so that won't work. So this is the only production rule that I can choose. That means this is unique. And then by my inductive hypothesis, this is unique. And if I glue together two derivations, the derivation that I get is also unique. So that means the derivation from S to beta is unique. And then for the case where B1 is 1, it's exactly the same argument. If you tried to put a 0 in the front, it fails. So this derivation here is also unique. So that gives us that all even-length palindromes have a unique derivation in the language, from the grammar, I beg your pardon. And if it's got a unique derivation, then it must be unambiguous. Okay? Which is the statement that we wanted to prove.